All right, section 5.5, law of sines. Okay, so we have done a lot of trig with right triangles, but not all triangles in the world are right. Some triangles don't have a right angle, and those triangles are called oblique triangles. Okay, so an oblique triangle is a triangle that has no right angles. And it's going to look something like one of these two triangles. Like this triangle on the left is where all of our angles that we have are acute. And then the height of this triangle, we could draw a dotted line and it would be inside our triangle. And then this one has an obtuse angle right here. The other two are acute. And then if we wanted to talk about the height of this, it would be outside of our triangle, the height of this triangle. Okay, without a right angle, we cannot use SOHCAHTOA to find the missing sides or angles or whatever of our triangle, like what we've been doing. But there's a couple of laws that we have that let us find the rest of the sides and angles. Okay, so before we talk about that, we need to review a little bit of geometry so that we're all familiar with these terms that I'm going to use. In geometry, you learned that two triangles are congruent if we know that the following information for each triangle is the same, starting with angle, angle, side. Okay, for angle, angle, side, I know two angles, and then I know the side that's next to one of those angles, not the side in between. Okay, that's not angle, angle, side. It means angle, angle, and then I have a side. Okay, so any triangle that has the same angle, angle, and side is going to be the exact same triangle. Angle, side, angle is where I have an angle, a side, and an angle where the side is between them. Okay, so angle, angle, side, the side wasn't in between them, but angle, side, angle, the side is between them. Then I have side, 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 which is where I know all three sides. That means that I can find all of the angles inside. And then side, angle, side is where I have a side, an angle, and a side, and the angle is between those two sides. Okay, so the first law that we're going to look at, and this is the law for section 5.5, is the law of sines. In some cases, we can use the law of sines to solve oblique triangles. This is what the law of sine looks like. It has two different forms. One is where you put the sines on top and the sides on the bottom. The other one, you put the sides on top and the sines on the bottom. So really quickly, let's go back and look at this set of triangles right here. Notice that the angle C, whoopsie, notice that the angle C is across from side C, and the way we represent that with it is with a big C for our angle, a little c for our side. Big B is the angle that's across from the side, little b. Big A is the angle that's across from side, little a. And that's, in general, the way we do triangles is to do it that way, to label so that they're like matching pairs. So on the law of sines, what we're saying is that, sine of A over the side that's across from angle A, which is little a, equals sine of B over B equals sine of C over C. And we're not necessarily going to use all three of these parts at once. This is basically a set of proportions. So if we know like three parts of this, like if we know angle A, we know side A, and we know angle B, okay, we would take just this part and set it up so that we can solve for what we're missing, which was a little b. Okay, so let's look at some examples. Example 1 is an angle, angle, side example. And they can give it to us one of two ways. They can give us the figure or they can give us the side links. Here I have both written down. And the figure isn't necessarily helpful because we've got this nice formula to plug into. What I can do is I can go ahead and write out my whole law of sines if I want. I don't know, well, before I do that actually, because right now I don't know A and I want to know A. Let's remember that if I know two angles, then I can figure out the third angle because all three angles have to add up to be 180. So 39 plus 52 gives me 91. And 180 degrees minus 91 degrees is 89 degrees. So I know that angle A is 89 degrees. And I would want to make sure that I let my teacher know that I know that A is 89 by writing something like A equals 89 and circling it. Okay, now let's write out the law of sines. Okay, so sine of A is sine of 89 degrees. I don't know what side A is. Sine of B would be sine of 52 degrees. And I do know what B is. Sine of C would be sine of 39 degrees. And then C goes on the bottom. Okay, so the two things I'm missing now, because I found the angle I was missing, the two things I'm missing are sides. Okay, and notice that the only thing I know both parts of the proportion for are the middle right here. So we're going to use the middle twice. We're going to say sine of 52 degrees over 15 has to equal sine of 89 degrees over A. And we're going to solve this and find A. And we're also going to do sine of 52 degrees over 15 equals sine of 39 degrees over C. Now the way to solve this is to cross multiply. Okay, I'm going to do this times this. So sine of 52 degrees times A is A sine 52 degrees equals 15 sine 89 degrees. So to solve for A, I would divide sine of 52 degrees on both sides. Okay, so now A is by itself, and let's talk about putting this into the calculator. What mode should our calculator be in if I'm typing in sine of 89 degrees? Shouldn't it be in degree mode? Why, yes it should. And in fact, definitely for this whole section, 5.5, you should be in degree mode. They didn't give us anything in radians in this section. Okay, so when you're typing this into the calculator, what I do is I put in 15 times sine of 89, and then I press enter, and then I make it to where it does answer divided by sine of 52. Okay, that's me personally. That's how I work it out. If you want to do it all at once, make sure you close the parentheses around 89. And might be a good idea to put the top in parentheses. I don't think that will matter. Try it and find out. See what happens. Okay, if I do this, 15 sine 89 and press enter, and then I divide by sine of 52, I get 19.03237406. So why don't we round that? I think in the section it says the nearest tenths. So this would be 19.0. So that's A. And then I would do the same thing for C, where I would cross multiply. So I'm saying C sine 52 degrees equals 15 sine 39 degrees, which means I'm going to divide by sine of 52 on each side. So C equals 15 sine of 39 enter divided by sine of 52 enter. I get 11.9792855.9. If I round that to the nearest tenths, that is 12.0. Okay, let's talk about the work that I want to see on a problem like this. I can assume that you could get A equals 89 just using your calculator. That's fine. But I want to see you plug into the law of sines, and I want to see in some form what you're typing into the calculator down here. Like, you don't have to do every single one of these steps, but I need to see something that shows me what you put into the calculator. So if that means that you write down this step, then do it. If that means you write down this step, then write that down. but I need to see something besides just you saying A equals 19.0 and C equals 12.0. Okay, so that's an example of angle, angle, side. Let's do an example of angle, side, angle. So again, we have the numbers written down, and we also have the diagram here. They could give us either one, really, and expect us to be able to do it. So because I know two angles, my first step is going to be to find the third angle. 34 plus 70 is 104, and then 180 minus 104 is 76. So angle A equals 76 degrees. And now I'm ready to set up the law of sines. So sine of A is sine 76, and then A is 33. Sine B, sine of B is sine of 34 degrees. And that's going to be over B, because I don't know what B is. And then sine of 70 over C. So now I need to figure out what B and C are. So my first fraction is the one that's complete. So it's the one I'm going to use twice. Sine of 76 over 33 equals sine of 34 degrees over B, and sine of 76 degrees over 33 equals sine of 70 degrees over C. Now you might be asking yourself after the last one why I'm using the first one the whole time. Why, if I find B, why can't I use sine of 34 degrees over whatever B is and use that to find C? And the reason is, what if you make a mistake on finding B? If you use B and you've made a mistake, then you can't get C right. But if I make a mistake on B and I don't use B, then I can still potentially get C right. So we want to use the information they give us as much as we possibly can. So I cross multiply this, and I get B, and that's a B, not a 6, B sine 76 equals 33 sine 34. Okay, so that we would divide this side by sine of 76. Okay, so in our calculator, this is 33 sine 34, enter, divided by sine 76, enter. So that's 19.0, which is something we got on the last one, which is weird. But you know what? Let's see it through. Okay, and then part C, I would say C sine 76 equals 33 sine 70 degrees. So C equals, because I'm going to divide by sine 76 over here. So 33 sine 70, enter, divided by sine 76, enter, gives me 31.9591874, so that rounds to 32.0. So that's different. I was worried for a second we were doing the same exact problem again. That would be bad. Okay, so that's how we would solve for angle, side, angle. Okay, now on the next video we're going to talk about a separate case which makes things more complicated.